Okay, so part 2 of section 4.2, Rolle's theorem. So here's our example, and it reads, let f of x equal x to the fourth minus 2x squared. Find all values c in the interval negative 2 to positive 2 such that f prime of c is equal to 0. All right, so I'm looking for c's on an interval a to b such that derivative is equal to 0. Now, this is only going to be true if Rolle's theorem holds. So number 1, is our f of x continuous? Well, our f of x is a polynomial function, so yes, it will be continuous for all real numbers. Definitely continuous for the interval from negative 2 to positive 2. Number 2, the second requirement is that f prime of x exists for all values but on the interval negative 2 to 2, open interval. Remember, continuous closed interval, derivative open interval. And since f of x is a polynomial, its derivative will also be a polynomial and therefore will be continuous on that interval. And then the third requirement is that f of a must be equal to f of b. So I'm going to go ahead and figure that out. What's f of negative 2? Well, let's see. That's going to be negative 2 to the fourth minus 2 times negative 2 squared. Okay? Negative 2 to the fourth is 16. 2 squared is 4 times, so minus 8, which is 8. And then if I do the other endpoint, that is f of 2 is going to be 2 to the fourth minus 2 times 2 squared. 2 to the fourth is 16 minus 8. 8. 8's 8. Same. Left endpoint, right endpoint are the same. So since those three criteria have been met, Rolle's theorem tells me there's going to be at least one value c. Now, given that this thing is a fourth degree polynomial, and I remember from college algebra that those things wiggle a bunch. Okay? And since they wiggle a bunch, there could be many c's. Okay? There could be, like 3 c's, depending on how this thing is set up? Because don't fourth degrees, since this is a positive leading coefficient, don't they do something like this sometimes? So if our interval was set up properly, we could find 3 values of c that all work. So I'm looking for at least 1 and potentially as many as 3 of these things. Now you might be wondering why I'm spending time even talking about that. It's always easier to find something if you know how many things you're looking for. So if I know that I'm looking for at least 1 but potentially 3, when I find 4, I know I screwed up. Or if I don't find any, I know I screwed up. Right? So what I want to do is I want to look for and find the appropriate number. All right, but in order to do this, the first thing I need is I actually need my derivative. So what will f prime of x look like? I believe it's going to be 4x cubed minus 4x. So then I will take that derivative and I will set that derivative equal to 0 and force this thing to happen. Now, what you will sometimes see is you will sometimes see people do this and replace these x's with c's because we're trying to find f of c when it's equal to 0. You're more than welcome to do that at this point and then work the entire calculation with c's in it. You can also leave it as x, but just remember that in the end, the answer isn't x equals 5. The answer is c equals. Okay? All right, so I want to do this. I'm going to factor. I get 4c times c squared minus 1 is equal to 0. I'm going to factor a little more. I got 4c times c plus 1 times c minus 1 is equal to 0. Okay? If 4c is equal to 0, that means that c is 0. If c plus 1 is equal to 0, that means c equals negative 1. And if c minus 1 is equal to 0, that means c is positive 1. So Rolle's theorem says there's at least 1, but how many did we find? We actually found 3 of them. Okay? So we found all the values c where f prime of c is equal to 0 when c is equal to 0, negative 1, or positive 1. Okay? Now, this is the point I was talking about. If you wrote this, technically you're wrong because we're not looking for an x. Right here, it says we're looking for c. And so really, to make this correct, I know this is being pedantic, but this needs to be a c. Right? And I get it. Sometimes it seems like people are just being mean to be mean and saying, well, you wrote C and you should have wrote X, or you wrote X and you should have wrote C. But as math gets more complicated, our need for precision increases. And so we need to be precise. Just in this problem right here, I'm dealing with a function f of x, I'm dealing with a function f prime of x, I'm dealing with a value for a, I'm dealing with a value for b, and I'm solving for values of c. And each of these different things means something different. I can't mix up my a's and c's because a's aren't c's. A is the left-hand point of the closed interval where this function is defined. B is the right-hand endpoint of this closed interval, and C represents the point somewhere in this interval where the derivative is equal to 0. So my labeling needs to reflect the precision that is necessary for the problem. So as math gets more complicated, precision gets more and more important. Okay. All right, here we go. Determine if Rolle's theorem can be applied, and if it can, find all values C. All right, so what are the requirements for Rolle's theorem? 1, is our function f of s continuous? Okay, well, there's our function f of x. F of x is another polynomial function. It's a quadratic. Okay? So therefore, it's continuous on all real numbers, definitely continuous on the interval 0 to 28. Okay? Number 2, does the derivative exist on the open interval 0 to 28? Okay? Well, if the function is a polynomial, its derivative will also be a polynomial, and those are continuous everywhere, so its derivative will exist for all values, definitely 0 to 28, so we're good there. Okay. Part 3, is f of a equal to f of b? Well, let's check. What's f of 0? Well, that's going to be 0 squared, negative 0 squared plus 28 times 0, which is a big fat 0. And then let's do f of b real quick. Oops, f of b is f of 28 is going to be negative 28 squared plus 28 times 28. Well, this is negative 28 squared, and this is positive 28 squared. So I really don't care what 28 squared is because I know those are going to cancel and I'm going to get 0. So left hand is 0, right hand is 0. This thing is good for Rolle's theorem. So now Rolle's theorem tells me C exists, go find it. Okay? Fancy term for this is a, what do we call this? This is an existence theorem. Rolle's theorem tells us that C, at least one C, exists. Doesn't tell us what it is. In fact, it doesn't even tell us how to find it. It just says it's out there. You go figure it out. Okay? All right, so first things first, I need my derivative. What is the derivative of negative x squared plus 28x? I believe that's going to be negative 2x plus 28. I will set that derivative, that negative 2x plus 28, equal to 0 and solve. When I solve, I get that x is equal to 14. So then I will say that f prime of c is equal to 0 when c equals 14. Did you see what I did on this one? On the last example, I switched to c's right away and just carried those through the entire equation. All the algebra that I did, solving for c, solving for c, solving for c. Here I did it more traditionally, where I leave it as x, but how do I report my answer? Well, when I report my answer, I say that c is equal to 14 rather than saying x is equal to 14. Because the problem asked me to find a value c, I'm going to give it an answer for value c. All right, next example. Determine if Rolle's theorem can be applied to f. If so, find all values c. So I should have, so same directions. Just now I'm going to have to determine if this works. All right, so first off, 1, is f of x continuous? Well, I've got an absolute value function, and I'm not necessarily good with those. So I'm just going to struggle for a moment here and try to figure out what this thing looks like. Let's see. College algebra taught me that I can look at something and recognize what it is based on translations, and that the original function for this, the parent function for this f of x here would have been just y equals absolute value of x, which looks like this when graphed, right? It's a v where the point of the v is at 0, and that this is going to be a horizontal translation right 3 units, and then that this is going to be a vertical translation up 4 units. So I'm going to take and move this 1, 2, 3, 1, 2, 3, 4, and I'm going to get a v over here like this. And so is that going to be continuous from 1 to 5? Well, yes it is. Number 2, is that going to be differentiable? Is f prime of x going to be differentiable? Well, and here's where things get tricky. I know that there's an issue with derivatives of absolute value functions. But the only time there's an issue with derivatives of the absolute value function is if we're worried about that cusp, that corner there. So is that corner on the interval 1 to 5? Because if that corner isn't on the interval 1 to 5, if we're looking at this piece over here, right? I'm sorry, we're actually at the light blue graph, aren't we? If I'm looking at this piece right here, then I don't have to worry about it. So 1 to 5, and where did we say it was moved 1, 2, 3 units to the right? So that's 3. That's smack dab in the middle of 1 to 5. So guess what? Rolle's theorem does not apply. Okay? All right, moving right along. Can I do Rolle's theorem on this one? Okay. Determine if Rolle's theorem can be applied to f. If so, find a value such as f prime. So the directions are the same. So there's nothing in the direction that gives me a clue as to whether it is or it is not going to work. The directions just tell me what to do. So I'm going to look at this one. Okay, well, what's the first requirement? Is f of x continuous? Well, that's my f of x. There's an x in the denominator. There's a fraction here. Fractions are discontinuous when the denominator is equal to 0. When will the denominator be equal to 0? Okay. So this thing has a discontinuity when that denominator is equal to 0. And so when is that going to happen? That's when x is equal to 0. Now this isn't necessarily a bad thing. It's only a bad thing if this value, 0 here, is in our interval a to b. And so is it in our interval a to b? Yeah, it's smack dab in the middle. So another one where we can write down the answer is no. Rolle's theorem does not apply. Now, if there was a question like one of these two in the homework, I believe what you would have to do is I think they want you to put NA for it. There'll be a note off to the side. If Rolle's theorem doesn't apply, type in blah, whatever that is. And I believe it's NA, but I'm not certain. So just be careful with that. Okay? So take a look at those, be careful, and see if you can make it happen. Right? All right, mean value theorem. I don't want to start mean value theorem in this video, so I'm going to stop this one and start a new one. That'll be part 3 for mean value theorem.